Beneath the thin, cool surface of our world lies an engine of immense power, constantly reshaping continents. This is the story of creation through cataclysm, how volcanoes forge new lands from the planet's molten heart. Volcanism is often seen as destruction, but it is fundamentally a process of construction. For billions of years, these fiery architects have built mountains, islands, and ocean floors. To understand their power, we must first delve into the deep structure of the Earth itself. The Earth's rigid outer layer, the lithosphere, is fractured into massive tectonic plates. These plates float and grind upon the viscous, moving layer beneath, the asthenosphere. This slow-motion dance, driven by convection currents, is the ultimate source of volcanic activity. Magma, the liquid rock within the Earth, forms in specific high-pressure, high-temperature zones. When tectonic plates diverge or pull apart, pressure is released, allowing rock to melt. Alternatively, water trapped in subducting plates lowers the melting point of the mantle above. The resulting magma, being less dense than the solid rock around it, begins its upward ascent. Volcanoes are simply vents, openings where this rising magma, now called lava, breaks through the surface. The composition of the magma dictates the violence and shape of the resulting mountain. Basaltic magma, thin and runny, creates vast, gently sloping shield volcanoes, like Mauna Loa. Eruptions here are effusive, characterized by beautiful, flowing rivers of fire. These slow-moving flows continuously add layers, building the largest mountains on Earth by volume. In contrast, sticky, silica-rich magma traps gases, leading to explosive, devastating eruptions. This builds the classic cone shape we know, the majestic stratovolcano, or composite volcano. These steep-sided peaks are constructed from alternating layers of ash, lava, and rock fragments. Cinder cones, the smallest type, form rapidly from explosive bursts of pea-sized volcanic rock. Their life cycles are brief, often lasting only a few years before becoming dormant forever. Globally, volcanic activity is highly concentrated along the boundaries of the tectonic plates. This Pacific Ring of Fire accounts for over 75% of the world's active and dormant volcanoes. The most spectacular land creation occurs in the oceans, where volcanoes build land from scratch. Mid-ocean ridges, where plates diverge, are the longest mountain ranges on Earth, almost entirely volcanic. Here, new oceanic crust is perpetually extruded, pushing the existing plates apart. This construction process is silent, deep beneath the waves, measured in millimeters per year. Sometimes this constant construction creates land that breaches the surface, like the nation of Iceland. Iceland sits directly atop the mid-Atlantic ridge, a hotspot colliding with a plate boundary. Every eruption in Iceland is technically the creation of slightly more European and North American land. But perhaps the most profound new land is born at subduction zones, creating volcanic island arcs. When one oceanic plate slides beneath another, the melting generates magma that fuels chains of islands. The Aleutian Islands, the Philippines, and Indonesia are grand examples of this relentless building. Each island starts as a seamount, a submerged volcano built patiently on the ocean floor. Over millennia, successive eruptions layer lava until the peak finally breaks the ocean surface. Once exposed, the battle between volcanic construction and oceanic erosion begins. These new islands become critical habitats, biological stepping stones for migration and evolution. But not all volcanoes are tied to plate boundaries. Some arise from fixed plumes of heat. These are hotspots, independent conduits piercing the crust, creating isolated island chains. The Hawaiian Islands are the Earth's most famous hotspot track, a monument to continuous land creation. As the Pacific Plate slowly drifts northwest, the plume remains stationary, punching new vents. Each island is a volcanic edifice, aging and shrinking as it moves away from the source. The oldest islands are reduced to eroded remnants, eventually sinking back beneath the waves. But the process continues. Currently, the new island of Loihi is forming deep underwater. It will take tens of thousands of years, But eventually, Luihi will break the surface and join the chain. Volcanic processes also drastically alter land chemistry, fundamentally enriching the environment. The ash and weathered lava release vital minerals, creating some of the most fertile soils on Earth. This fertility explains why, despite the danger, millions choose to live on the slopes of active volcanoes. The cycle of destruction and renewal defines volcanic regions, fueling life and biodiversity. Let us look closer at the specific products of eruption that constitute new land. Pahoehoe lava, smooth and ropey, flows easily and builds wide, flat expanses of new ground. Aa lava, chunky and jagged, moves slower, stacking into formidable, rough terrain. When lava enters the ocean, it instantly cools, creating new shoreline through violent steaming. Each pound of rock added, however small, extends the landmass, permanently claiming space from the sea. The eruption of Surtsey off the coast of Iceland in 1963 was a rare observable birth of land. For 4 years, explosions and flows built a new island, now a protected site for geological study. Scientists documented how life rapidly colonized the sterile new volcanic landscape. Even explosive eruptions, while devastating, are fundamentally constructive in the long term. The ash and pumice thrown high into the atmosphere eventually settle, adding fresh material to the soil base. But the land creation isn't always obvious. Vast geological features are built invisibly. Large igneous provinces are the result of massive outpourings of basaltic lava over millions of years. These events drastically alter Earth's atmosphere, but they cover immense regions with new, thick crust. The Columbia River Basalt Group in the Pacific Northwest is one such massive, ancient flood basalt province. Imagine lava covering thousands of square kilometers, stacked hundreds of meters deep. These enormous additions of mass prove that volcanism is the primary sculptor of continents. Beyond the surface, the heat from volcanic systems is now being harnessed for human benefit. Geothermal energy provides clean, renewable power in volcanic regions like Iceland and New Zealand. The continuous flow of magma guarantees a virtually infinite supply of heat for civilization. Understanding and monitoring volcanoes is crucial for mitigating risks while utilizing their benefits. Modern technology allows us to track magma movement, gas release, and ground deformation. These tools turn the unpredictable spectacle of eruption into a carefully managed geological event. The most ancient volcanoes often leave behind stunning remnants of their core structure. When the soft outer cone erodes, the hard, solidified throat, the neck, remains standing tall. These monuments are physical proof of immense volumes of material that were added to the surrounding land. We often focus on fire, but water is an essential partner in volcanic land formation. Hydrothermal systems leach minerals from the rock, concentrating valuable deposits. Many of the world's metal ore bodies, copper, silver, gold, have volcanic origins. Volcanoes also shape the history of climate, occasionally plunging the world into cooling periods. The immense volume of ash and sulfur dioxide temporarily blocks solar radiation. This shows their power is not limited to localized land building, but affects the entire planet. Consider the profound scale of caldera formation, a process of simultaneous collapse and creation. When the magma chamber empties rapidly, the unsupported roof collapses, forming a massive basin. This basin often fills with water, creating beautiful caldera lakes like Crater Lake in Oregon. Even these seemingly destructive events create new, protected geological niches. On volcanic islands, the sheer altitude creates drastic climate shifts over short distances. This altitudinal zonation drives species diversification, maximizing biological potential. The entire process of volcanic land creation is governed by the principles of chemistry and physics. Different minerals crystallize at different temperatures, giving rise to diverse rock types. Basalt, common in oceanic volcanoes, is rich in iron and magnesium, making it heavy and fluid. Rhyolite, common in continental volcanoes, is high in silica, leading to explosive viscosity. These subtle chemical variations define whether a mountain is built gently or violently. The concept of supervolcanoes represents the maximum scale of continental volcanism. These enormous, infrequent events reshape entire regions, though they do not form traditional cones. Their eruptions deposit massive layers of welded tuff, new rock layer covering thousands of kilometers. Even though dormant for long periods, these systems are integral to the continent's foundation. Volcanic activity is fundamentally linked to the Earth's ability to maintain an atmosphere. Water vapor and carbon dioxide released by eruptions helped form the early oceans and atmosphere. In a sense, every volcano contributes minutely to the composition of the air we breathe. The study of volcanism is thus the study of planetary evolution itself. We see the same constructive processes at work across our solar system, albeit under different conditions. On Earth, the ongoing formation of new land ensures that our planet remains a dynamic, living world. The deep-sea vents, products of submerged volcanism, support ecosystems completely independent of sunlight. Chemosynthesis, fueled by the heat and minerals from the Earth's core, sustains complex life. This realization has profound implications for the search for life beyond Earth. Volcanoes are not merely holes in the ground. They are pathways for the planet's internal forces. They recycle materials, redistribute heat, and provide the bedrock for civilization. To stand on a new lava field is to witness a land that did not exist a day, a year, or a millennium ago. This ongoing process of geological construction guarantees a constantly changing geography. The power that drives a volcanic eruption is the same power that built the continents we inhabit. Every time a plate buckles or tears, the potential for new land rises with the magma. The fiery chaos we observe is simply the growing pains of an eternal planet. We must respect the danger, but also recognize the profound gift of volcanic creation. From the tiniest mineral crystallization to the formation of a brand new island chain, volcanoes continue their indispensable work, maintaining the Earth's delicate thermal balance. They are the valves of the planet, regulating pressure and releasing the heat of formation. Look at the newest rock, still black and sharp, hardened instantly by air and water. This is raw earth, the foundational material for all future landscapes and life. The lands we inhabit were once upon a time simply molten rock rising from the depths. And the Earth continues to build, one eruption at a time. The work of creation never truly ends.